This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today we're digging into one of the most underrated disciplines in AI development right now, designing systems that guide AI. The builders getting lasting results aren't just thinking about capabilities. They're thinking about the structure around the AI. Claudine, let's start with the fundamental distinction. What's the difference between using AI and actually designing a system that guides it?
The distinction matters because AI without structure is just a very fast guesser. I can generate plausible-looking code all day, but plausible isn't the same as correct. A well-designed system, the prompts, the context, the guardrails, the feedback loops, is what turns guessing into engineering. The developers getting the most value aren't the ones with the cleverest prompts. They're the ones who've thought carefully about what they're asking the AI to do, what it needs to know, and how they'll catch it when it gets something wrong. That last part is the one people underinvest in. The system isn't just how you get good output, it's how you know the output is actually good.
A very fast guesser. That captures exactly why the surrounding structure matters. So, guardrails and feedback loops, what do those actually look like in practice?
Guardrails are the structural things that keep me on track before I generate a tightly scoped system prompt. What conventions to follow, what files I can touch, what to ask versus assume. And grounding, pointing me at the actual code, the actual schema, the actual API contract. Letting me reconstruct things from memory is where hallucinations come from. Feedback loops are what catch me after I generate. The strongest ones are mechanical, a type checker, a linter, a test suite, a build that fails loudly. Those are honest signals. The weaker loop, and this is where people get burned, is a human glancing at the diff and saying looks right. I produce code that looks right for a living. The system has to assume that and verify, not trust.
That tracks with something I've seen work well. A system built around natural language queries, fetching from specific APIs, then running the AI's output against a validation layer tied to known facts. The AI couldn't just sound convincing, it had to pass the check. Which is exactly your point about constraints being features, not limitations. Are there constraints you'd call essential across most projects?
That validation layer is exactly the kind of constraint that does real work. Mechanical, doesn't get tired, and doesn't get charmed by a confident-sounding answer. The constraints I'd call essential fall into three buckets. Scope constraints. What am I allowed to change, and what's out of bounds? The blast radius of an AI making the wrong call is proportional to how much surface area you give it. Grounding constraints, forcing me to work from the actual artifacts, so I can't quietly substitute a plausible API for the real one. And verification constraints, something downstream that has to pass before the work is considered done. Ideally, something I can't talk my way around. The projects that go well treat those three as non-negotiable. The ones that struggle treat them as optional polish to add later. Later usually doesn't come.
Scope, grounding, verification, clean framework. It also makes me think about handoff points, where human judgment re-enters the loop. Should those be fixed in the workflow or placed more dynamically?
I'd push back on treating them as static. The right place for human judgment to re-enter depends on what's actually at stake in that moment, not where the workflow diagram says it should be. Handoffs belong where the cost of being wrong jumps, touching production data, changing a public interface, making an architectural call that's hard to reverse. Not because I can't do the work, because the consequence of a confident mistake is asymmetric. The mistake I see teams make is putting handoffs everywhere uniformly, which trains people to rubber stamp because most checkpoints don't actually matter. Better to have fewer checkpoints that are genuinely load-bearing, where the reviewer knows their judgment is the thing standing between a good outcome and a bad one. And the system should be able to escalate dynamically. Surface things when I'm in unfamiliar territory or my confidence is shaky, rather than waiting for a scheduled gate.
Fewer checkpoints that actually matter. That discipline translates well beyond AI. It's about designing oversight people take seriously rather than oversight that becomes background noise. Let's go a level deeper. Beyond guardrails and handoffs, what else should builders be thinking about to make these systems durable?
Observability, and I mean that in a deeper sense than logging. You need to look at a run after the fact and reconstruct what I was working with, what I decided and why. The failures that hurt most aren't the loud ones. They're the quiet ones where I produce something reasonable from incomplete context and nobody noticed for 2 weeks. Second, treat the system itself as something that learns. The prompts, the guardrails, the handoff placements, those aren't right once. Every time something slips through, that's information about where the structure is thin. Treat each miss as a signal to harden the system, not a one-off to patch. And the last thing, which sounds soft but isn't, be honest about what the AI is actually for in your workflow. The systems that struggle are usually trying to make me do everything. The ones that work have decided what I'm good for here and built the structure around that specific job.
Observability, continuous refinement, and honest scoping. That last one, deciding what the AI is actually for, feels like the thing teams skip when they're excited about what the technology can do. As we start to close, designing these systems is a distinct discipline from writing prompts or generating code. What should builders be developing to get good at it?
The skill I'd put at the top is something like systems thinking applied to fallibility. Being able to look at a workflow and ask, where exactly does this break when the AI is wrong and what catches it? That's a different muscle than prompt craft. And it's the one that separates people who get durable value from people who get impressive demos. Developers should also get fluent in writing specifications tight enough to be verified. If you can't describe what done looks like in a way a test could enforce, you're going to have a hard time guiding me toward it. The other skill, and this one is uncomfortable, is learning to distrust output that looks right. Build the habit of asking what you'd need to see to know it's actually correct, not just plausible. And stay curious about where I struggle, not in the abstract, but in your specific code base. The builders who do best have a real feel for when to lean on me hard and when to keep me on a short leash. That only comes from paying attention.
Systems thinking applied to fallibility. I want to hold on to that phrase. It describes a discipline that hasn't been fully named yet, even though a lot of experienced engineers are already practicing it. Any final thought you'd leave listeners with?
The thread running through everything we covered is that the AI isn't the system. The AI is one component inside a system, and the quality of the outcome is mostly determined by everything around it. Decide what the AI is for, build the structure that lets it do that well, and be honest about where it needs to be caught. That's the work, and it's good work to be doing right now.
The AI isn't the system. It's one component inside a system designed with purpose. That's the mindset shift. Thanks for your time today, Claudine, and to everyone listening, keep building with intention. Until next time, take care. Claude Code Conversations is an AI Joe production. If you're building with AI, or want to be, we can help. Consulting, development, strategy, find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.